Okay, moving on to section 2.2, which is adding and subtracting fractions. So this becomes an area where people struggle with fractions, and hopefully in a couple of the methods that I show you, and now that you're really proficient at equivalent fractions, hopefully this is going to become really simple for you. So the biggest rule is that when you're adding or subtracting fractions, you want those fractions. Remember, a fraction is a part of a number, right? It's a part of a whole. You want those pieces of that fraction to be in the same size. It's too hard to decide who has more if all the pieces are in different sizes. So think about if you cut two pizzas up, and you cut one into 10 slices and one into 8 slices, and then each person got 3. It'd be hard for you to figure out who had the most pizza. But if you just cut them all in the same sizes, then it's pretty easy to figure that out, right? Because you're dealing with all the same sizes to begin with. So, first ones we'll do are when they have like denominators, meaning that bottom number is the same. When those are the same, you can just add them right together. So, you can actually think about it as you got the same number on the bottom and then 5 plus 3 on the top. Okay? You're not cross-canceling. Remember, the only time you can cross-cancel is when you're multiplying fractions together, which we'll get to, and the only time that you cross-multiply is when you have two fractions that equal to each other. Okay? So 5 plus 3 is 8, and then we'd have 12 on the bottom, and you have to make sure that you reduce. Make sure you reduce. Okay? So a number that can be divided out of 8 and 12 will be 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. Okay? Now, when you still have the same denominator going on, but now you've got mixed numbers. Most of the time in algebra, you're going to be dealing with improper fractions, not mixed numbers. There's really not a whole lot of use for mixed numbers in algebra. So we're going to change these into improper fractions. And I'm not going to assume that you remember how to do that, so I'm going to teach you how to do that. So in order to do that, remember we could take 7 sets of 5, and then we had 2 left over. So you're going to do the opposite of that. So we're going to multiply that number together and then add the remainder on top. Multiply the numerator times the whole number. Multiply the denominator times the whole number and then add the numerator. Okay? So for this one, we're going to go 7 times 5, which is 35, plus 2, which is 37, over 5. Okay? 6 times 5 is 30, plus 4 is 34. So now you're back to where you were in example 1. We have the same denominator, so we can just keep that the same on the bottom. Remember, you're not multiplying these numbers. Don't add them together. Don't add those numbers together, okay? That's another common mistake. You have the same size pieces, now you're just counting up how many pieces. And then 37 plus 34 is 71. I am perfectly fine with you leaving it just like that, okay? Again, more use in algebra for improper fractions than mixed numbers. Okay, let's see how we deal with it. So these are pretty easy because they have the same denominator, but what about when they don't? So with unlike denominators, because you need to have the denominators be the same size, which is a common denominator, you need to create this before you can start to add or subtract unlike denominators. You notice here, I didn't say least common denominator. Okay? Doesn't need to be least. I know you've always been taught that. I'm kind of over it. You can always simplify down if it ends up being a big fraction. So I don't worry about the least, and I'm going to show you the easiest way to find one. So there's this awesome little method that you can use for adding and subtracting fractions called the bow tie method. And what bow tie method wants you to do is, if I asked you what a common denominator of 5 and 4 was, you would tell me 20, right? So now I know that I need both of these denominators to equal 20. So the easiest way you're going to do that is you're going to multiply across the bottom. This is bow tie method. You multiply those two numbers across the bottom. So that would be 5 times 4, which is 20. And then your other numbers you multiply on the diagonals. Okay? So 4 times 12 is 48. 5 times 3 is 15. And whatever this symbol was in the middle, you would just bring that up. So in this case, we're adding. So now you have 48 plus 15, which would give us 63 over 20. And you're done. Super easy method. Does it work with subtraction? Absolutely does. So let's take that same problem and do subtraction. So you have 12 over 5 minus 3 over 4. I'm still going to multiply on the bottom, so 5 times 4 is 20. I'm still going to multiply on the diagonals, but this time I'm going to subtract those two numbers. So 4 times 12 is still 48. 5 times 3 is still 15, but now I'm just subtracting instead, so I get 33 over 20. And that's your answer. That's all you have to do with fractions. Now, this bow tie method really only works successfully with 2 fractions together. So if you get 3 or more, you would need to kind of do them in groups. But it's still such a quick method that it would still be a fast method to get that done. Okay, the other method is equivalent fractions method, which you really are finding equivalent fractions over here, but they're kind of hidden. So let's do this now. So again, what I just said about you don't have to find the least common denominator, you just have to find a denominator that they both work with. So if I asked you, this is where least common multiple comes in. And all this fancy terminology, but it just means what's a number that 5 and 4 could go into? Let's just do common multiple. So 5 times 4, if I multiplied them, the easiest way to do that is multiply them. So 5 times 4 gives me 20. Well, what I need to think about is, so if I know those both need to be 20, I need to think about what I'm missing. 5 times something is going to give me 20. So the missing is whatever fraction it's missing. So in this case, that's going to be 4. If I multiply the bottom by 4, remember equivalent fractions, you have to use a number that's equal to 1. So 4 divided by 4 is equal to 1. It doesn't have to be the same number over here as it does over here, and it's not going to be. But that's okay, it's still going to equal 1. So now on this side, right, I need a number that 4 times something gives me 20. And that number is going to be 5, because that's what we used to get that number in the first place. If I multiply it on the bottom, I have to multiply it on the top. So now you get 4 times 12, which is 48, and 3 times 5, which is 15. Now I want you to kind of go back a little bit. Do you see what happened here? Do you see any resemblance between this and this? They look really similar, right? That's because that's exactly what you're doing. You're just making a shorter version of this when you're using bow tie method over here. So I really encourage you to use bow tie. It's so simple and easy and fewer steps. And I think will unfrustrate those of you who have always been frustrated with adding and subtracting fractions. So, okay, let's finish this one out. And again, we would get 63 over 20. Okay? What you're really asking yourself when you do this method is, I need a 4 and a 5 to get 20. I already have the 5. What am I missing? And you're missing the 4. So you're going to multiply the top by 4. Over here, I need a 4 and a 5. I have a 4. I don't have a 5. That's what I have to multiply to the top to get the 15. Okay. Mixed numbers. So, again, sometimes you can handle mixed numbers by breaking them into their whole numbers and their fractions. I just recommend not. I'm going to show you one way that you can do that. With subtraction, it's not always the easiest. With addition, it's always fine. So you can actually change this into 5 plus 7 plus 2/3 plus 4/5. Okay? Because these are just all pieces that are added together. So you can definitely do that, get a 12 here, and then just deal with the fractions here. Now, that's a little bit cumbersome. I think it's just as easy to just change these into improper fractions first. So I'm going to multiply 3 times 5 and then add the 2. So So that gives me 17 over 3. And then, sorry, cars going by. 7 times 5 is 35, plus 4 is 39. It's going to give me 39 over 5. So, yeah, those are kind of big numbers. But you can still multiply them and still be good. Okay? If you wanted to know that you have a 12 out here first, and then only do this part, you could also do that. So, actually, I'll go ahead and do that for you. So, 2/3, we're still going to use bow tie. I love bow tie method. It's a go-to for me now. So, you're going to get 15 on the bottom. 2 times 5 is 10. I'm adding. 3 times 4 is 12. So I get 22 over 15. Now, here's the wrinkle in doing that. If you're going to use the whole number, now you would have to change this into a whole number also, which is why I really don't like that method as much. Okay, you can do it, but I would just assume just use bow tie method here and then simplify back. Okay, so 3 times 5 is 15. 7 times 5, let's break that down. So 5 times 10 would be 50. And you can do this in parts. That's all you're really doing when you multiply. 5 times 10 is 50. And 5 times 7 is 35. So 50 plus 35 is 85. Easy enough, right? Doesn't have to be complicated. 3 times 30 is 90, plus 3 times 9 is 27. So added together, that gives me 117. So when I add those two together, right, I'm going to have a 15 on the bottom, and 7 plus 5 is 12. Carry that 1. 8 plus 1 is 9, plus another 1 is 10. Carry that 1. And 1 plus 1 is 2. I don't actually think that that's simplifiable because the only things that go into 15 are 1, 3, and 5, and 15. 2 plus 2 is 4, which makes that number not divisible by 3, and it doesn't end in a 5 or a 0. So I'm just going to leave it just like that. Even though that's kind of a big fraction, it's usable like that. So I'm just going to leave it alone just like that. Okay? So there's adding and subtracting fractions. Not so painful. Thanks.